Looks like there's a few of you in the channel. Can you guys hear me? I can see a few people join the channel. Sorry, I forgot that I had actually sent out the original time for this at 7 o'clock and I pushed it back to 7:30. Hopefully that didn't inconvenience too many people. Let me know if you guys are able to hear me properly, if I need to turn up the gain on my microphone. Sorry, I'm using a mechanical keyboard, so it's a little bit loud. All right. Let's see. Does anybody have any questions that they want me to answer, like right away? Like, we still got like 5 minutes before I'm officially starting the stream. So if you guys have any questions about anything that you want to ask really quickly, um, about the exam, just in general, feel free to ask now. If you want to get anything, any of the stuff that we're going to be using for the review, you'll want to just go to the link that I've provided there. It's under, I think it's under the channel feed. So you can go to web.njit.edu/tilde UTC2, and it'll have a link to all the folders and stuff where I have this stuff saved, so you guys can just grab the stuff from there. Let's see. Yep, go ahead. Oh, so when you're writing function names like that, right there, that actually looks a little bit like a mix of the Python style and something called camel case. If you program in Java and C, typically the style will be like that. Where if you have like a function, so I don't know if you put that underscore there on purpose, but in like JavaScript, not Java, well, JavaScript as well, and Java and C and C++, you'll get variable names that will be like big count, and function names that look like this as well. So that's just the style for doing that. In Python, there's actually like a standard for it, and the suggestion, if you want to look it up, it's called PEP8. Uh, and the standard for that is if you want to write a function called big count, you actually write it like this, and you use underscores instead of using camel case. It's just a preference thing, but people who typically program in Python will be used to seeing variables and functions being written with underscores instead of camel case. And if you work in multiple languages, like a lot of developers do, you might get a little bit confused when if you're working with Python code for a while and then you have to transition to working on somebody else's code, and all of a sudden you start seeing camel case and you're like, oh, I thought I was working in Python, but this looks like Java, and then you're like, oh, it's still Java, but I mean, this is still Python, but somebody just decided to code it in camel case. So if you're coding stuff in Python, try not to use camel case. Most other languages will use it, but in Python, just get used to using underscores. Yeah, it's a style thing. So just be consistent about it. Let's see. The material should be about the same. Last year was when we started doing dictionaries and tuples earlier. So if you just want to watch last year's stream, I think it's still up on my YouTube channel. I'll check again. Um, but it'll be a different exam than this one. But the content will be exactly the same. All right, so it's 7:30 now. I'm gonna get started. I think at 2 or 3 TAs, hopefully. I don't know. I know Chris is here. He might be back in a little bit, and I had another TA. Let me check really quickly. Who said they'd be available? Oh, Jason Diaz. I think he's here already. Yep, he's here. Okay, so yeah, it looks like tonight we have Jason and Chris helping us. So if you guys have any questions, what will happen is I'm primarily going to be focusing on the review and the materials I prepared, as well as going over the exam. If you have specific questions about some of the questions and stuff in there, feel just type in the chat, and Chris and Jason will help you with it. I'm going to be trying to just concentrate on getting through everything. There's a lot of stuff to cover for this review, so I'm just going to keep moving. So again, they'll help with specific questions. I'm just going to cover the stuff I have prepared for this. All right, so for the second midterm, it's cumulative, so you're gonna need to know everything that's on the previous exams as well. So that would be variables, input, output, input, um, strings, lists, and whatever else I've forgotten in that grouping of things. So you need to know all the stuff from before. I think there's like for loops and if else as well. And you need to know the new content that we covered for this section of the semester, which are while loops, file input output, dictionaries, tuples, which are fairly easy and straightforward. We'll go over them really quickly, and then some string methods that might help you out a bit. So let's see. Yeah, you're gonna need to know all this material. This pretty much covers almost everything you'll need to know. I think we cover classes and maybe one other thing in scope for the final, and you'll need to know classes, but the way we have it structured is fairly straightforward. So this is pretty much the last of the stuff you're going to need to know, so make sure you understand this stuff fully. All right, so the first thing that we're going to cover are loops. You should already know how to work with for loops, so I'm not going to cover them in detail other than just discussing them really quickly. So with loops, they're just control structures. What you're doing with loops is you're trying to, like other control structures like if and else, is you're trying to use them to group and organize code together that has specific usages. In this case with loops, it's code that's going to be repeated, and you want to group it together so that instead of writing the same code over and over again, you can use that control structure to make the code run again. If you're working with loops and you're not just looping over something and printing out the stuff, if you're actually trying to keep track of some things, like if you had a counter where it's counting the number of occurrences of something, or if you're trying to store all the occurrences of a substring inside a list or something like that, you need to keep those accumulators outside. I'll have a example of that coming up. And there is also the possibility that your loops can be nested, so there can be loops inside of other loops. All right, so for loops, just quick review for this. Iterates over a sequence, guaranteed to terminate. It's going to iterate over every element inside whatever sequence that you've provided it. So again, remember, this is for sequences. All right, the variable name is built into it. So you'll see, can you guys see the cursor on this thing? Maybe it's not capturing the cursor. Give me 1 second. Okay, so you guys can see the cursor. Okay, so if you look on the right side here, this element thing, you can replace it with, you're supposed to replace with a variable name. So this one, the variable name is built into this structure. So this is the structure for a for loop. It's for each element inside whatever sequence you give it. And remember, this has to be a sequence, and that's either going to be a string, list, tuple, or dictionary. Whatever is inside that sequence, it's going to go one by one, and this variable that you have here, whatever you put in, is going to take on each value at a time, and then you're just going to do whatever you need to do with that variable. All right. So you can do that. You use this when you have a sequence or something that's a set length, and you know how many times you're going to go through it. The one that we're more interested in is while loops. So while loops, which is what we've covered in this semester, are conditional loops. They require some kind of condition here before they run. So with the for loop, if you looked at this, the syntax is like this. There's no condition inside here. It's for this entire sequence is going to go through the whole thing and do it. But the while loop is not like that. The while loop has some kind of condition here. So it's while condition. And the only way the while loops work is while this condition is true. Right? So you can use this to you can just use this to loop. Um, and if you want to actually track variables and stuff, whereas in the for loop you already have the variable built into it, while loops require that you have the variable created elsewhere, typically outside. So let's see. So you should have in the homework you should have seen two types of while loops. There should have been one where it's just while true, and then one that's while some other condition, right? So while true loops are technically they're infinite loops. They'll run forever because true is always true. So this code will, if you didn't have this if condition here with this break, this would run forever because while true is always true. So it'll keep going. So the way you were taught to get out of this was to use break, and then so you just check if if this condition is true, break, and then break out of the loop. So one thing that came up that I thought was interesting when I was working with another student was trying to look at the way this thing worked because this was the first thing you were taught, and then the second one, which was the second version that you have been taught, was checking some kind of condition. So while this condition, run this code, right? So I structured it this way. I structured this image this way because I wanted you guys to actually see how these two are related to each other. So when you're looking at while true, this thing is always going to go and you're looking for a condition that makes this thing break, right? So when you're looking for this, when you're trying to get this condition here, when you're trying to get it into just a single statement without including an additional break, what you're actually looking for is you're trying to see how can I make this condition false, right? So this one is always running, and then when it hits this condition being true, then it breaks. So this thing is kind of the flip of that, where you're trying to say, all right, while this condition is not true, right? While this condition here up here is not true, this will keep running, right? So what you want to do is you want to, if you build something like this, where if it's while this condition is true, while this condition, once you find this condition that breaks, then you're trying to find the opposite of this condition. So if this was if x is greater than 1, then break, your not condition would your opposite condition for building this loop would be I said x is greater than 1, so this would be less than or equal to 1. So it's taking the not of that, right? So that's another way of thinking about it when if you're trying to structure this condition. If you're writing the code on the exam and you just want to use the while true loops, you can do this and figure out the conditions to make it break. If you want to do it this way and you're having difficulty visualizing how to come up with this condition, just think about how to make this thing break and then do the flip of that. All right, so that's pretty much it for while loops. Okay, so there's additional flow control stuff. I used break in the previous example without going into detail about it. So I want to talk a little bit about break and continue now. So both of these are flow control things. They fit inside loops, particularly for and whiles, and they help you to determine what you want to do with the way the code works. So what break does is it's going to terminate the loop. It's going to stop the loop wherever the break gets hit. If you think about it, it works for loops the same exact way that the return statement works for functions. As soon as you hit a break, you're going to pop out of whatever loop you're in, and you're done with that loop. Same way that, if you hit a return statement inside a function, you kick out of the function with whatever values you currently have. So that's what break does. If you have a nested loop where you have a loop inside a loop inside a loop, and you have a break, the break will only affect whatever loop it is currently in. So if you have a break inside the inner loop and it hits that, it's still going to go back out and rerun the outer loop until it's done with the outer loop. All right. So break statements and continues will only affect the nearest things, the currently active loop that you're inside. All right. And continue does something similar, but it doesn't kick you all the way out. It just says, all right, I'm done here. Stop running this. Stop this loop. Go back and continue doing the rest, and then just do the next iteration of the loop. So what happens here? The example for that one is for I in range of 5. This thing will generate a list or a list type sequence where it's going to be 0, 1, 2, 3, 4. I'm just checking for evenness here. So if I mod whatever value I takes on modulus 2 is equal to 0. If I find an even number, I'm not going to do anything. I'm going to continue. Right. So I'll hit a continue here. It says don't execute any of this code after this continue statement here. If I hit this continue, if I find an even number, just go to the next value. Otherwise, if I do find an odd value, so 0 goes through, 0 mod 2 is equal to 0, continue, skip this print statement, then 1 mod 2 is equal to 1, so I skip this statement here, and then I execute this one, so print out 1. Then 2 does the same thing, hit the continue, skip this, and then so it'll keep going and it'll print out 1 and 3 when you do this statement here. All right, so this is using continue. Just skips whatever's after the continue statement and then goes to the next iteration of the loop. That's what's always going to happen with that, using continue. So with break, it's the other thing. Break is, let's say I start off with a password here of nothing. I'm just going to have this thing loop until we find that somebody types in a password that's greater than or equal to 8 characters, right? So if I pass in this the first time password has a length of 0, so this is clearly false, don't run this thing, it'll ask for a password. Now I type the password in, right, and it saves into password, go back, it's going to go back because while loops run, while this is true, and this is always going to be true, so it's going to keep looping. Goes back, the password I typed in, let's say it was 4 characters, length is less than, it's going to skip this thing, ask me for another password, let's say I typed in the password, right? So now password, if it checks the length of password is 8. 8 is greater than or equal to 8. Comes in here, it says print password, okay, so it's going to print that out, and then it will hit this break statement and kick me out of the loop. All right, so then that just stops running the loop and it's done. All right, so that's how break and continue work. All right, so the next thing I want to cover then, actually, first of all, any questions about while loops really quickly before we move on to the next thing? All right, so if there's no... Oh, okay, so I said the best time to use a for loop is when you know the number of times it's going to execute because you have a sequence that's of a set length, right? With a while loop, it's usually something other than that. While loop is something where you don't know how long it's going to take, right? So in this case, it's like saying, if you're asking the user to type in a password, there's no guarantee that they'll ever type in a password that is the correct length or of the correct requirements. So in this kind of situation where you have no guaranteed termination, you'll want to keep doing that. You want to use a while loop so you can keep checking until you've met a condition, right? So the difference between a for is for you already know your sequence, you know how long it's going to take. Go ahead and iterate over it. while loop is you have no idea how long this is going to take. It could take, it's a condition where you're trying to find if something is true or false. That condition might never be true, right? And then in that case, you want to have a while loop where you're checking for that kind of stuff and just going forever. All right. So the next thing you need to know is file input output. This stuff is pretty important. It is guaranteed to be at least, I think it's almost always problem 12 on the multiple choice. Not the multiple, sorry, 12 on the free response. So you will have to do file IO with this. Right? I want to try to keep this as simple as possible. Um, so the reason file stuff is important is because you don't want to just constantly have to figure out get data from the user or something like that. You want to be able to read and store data for later use. You want to be able to save some property files or something like that, or you want to be able to, like, if you were keeping track of your grades or something, you want to store that data somewhere so you don't have to type it in every single time, right? Am I too quiet? Hmm. I mean, it looks like everybody else is able to hear. Maybe I could turn up my gain a little bit, or is it loud enough? Okay. Make sure if you got headphones on, they're plugged in correctly. Or just make sure the stream is, yeah, make sure the audio is, the volume is set up high enough on your computer. Okay. All right. So, files are really straightforward. There's only really two things you can do with files. It's there's one operation which is opening and closing them, and the other operation which is reading from them and writing to them. So files are really, really straightforward. Don't overthink them. All right. So the main thing with opening files is, when you open a file, the structure of the command is just open, and then some file name and extension. If you don't have an extension on the file name, that's fine, but this thing has to be a string, and then some value in here, also a string for the second parameter, where it's either going to be read, write, or read plus, which is, I think there's also a as well. A is for append. Make sure you look that up and know which ones they are. Typically the only ones you will use are read and write. All right, so this command here will always return something called a handle to a file, to this file. The idea is that this thing says, okay, so here's a file that I've opened up, and I'm going to either read from it or write to it, and then it's going to give me some kind of way to get to it. All right, but if you don't save that handle, it's just gonna vanish. Right, it's gonna go into the ether, so you can't use it anymore. You can't access it. So you have to save it somewhere so that you can access it again. So what you do is you store it in a variable, right? So if I wanted to, so this is something that I do. If I'm reading from a file, I'm just gonna call it fin for file in. If I'm reading if I'm getting a file that I'm going to write to, I just call it f out. It's just, these are standard variables that you can use. Feel free to use them on your exams if you don't want to think about it. This is the structure that you want to use, though. All right. So you want to open the file, store that inside some variable so you can access it. All right. So once you've stored it into the file, there's actually several ways of accessing that data. You can read it directly from a stream, which is, whatever the handle is. That's actually, so what it actually is it actually the handle that it gives you is actually a file stream. It's actually a stream of data. It opens a channel with a stream of data that you can actually read data directly from that stream. So if you want, if you do it that way, you can actually just go ahead and you can look at it like this. So if we do the crap, did I miss a file? Oh, sorry. So yeah, I should have gone over this first, because some of the code there was a little bit wonky if you're not familiar with it. Okay, so this is a discussion of old versus new style syntax. You can use either one of these on the exam. Both of them are fine. If you use the old style, which is you open the file. So this one, I want to open a file for reading, save it into fin, file in. open a file for writing, save it to F out. I'm going to do stuff with that code, and then I'm going to close. You have to close it if you're using this old style. If you don't have these close statements, you're going to lose points. That's just how it is. Right? You have to close a file. I think when we were actually testing it out in class, when if you didn't close the file, it wouldn't actually, if you were trying to write stuff to the file, so if you did like fout.write something, if you didn't close it, it wouldn't actually write to the file. All right, so you have to, if you're using this syntax style, you have to close your files. All right, so if you open, you have to close. All right, the way that I would suggest using it, again, if you're not familiar with doing this and you don't feel comfortable doing it, don't do it. All right, if you're used to doing it the old style, do it the old style. You won't lose any points, unless you forget this close thing. Using this with statement. So with is a statement that's provided with Python. It was introduced in Python 2.5, if I remember correctly. But the way it works is that with is a handler, a special type of handler that can look inside code as long as the code is set up correctly. So it can look inside this open method, and the person who wrote the open method went inside there and actually coded additional things in there so that it would handle this. It would be able to handle stuff through the with. So they realized that if you open a file, you're going to want to close a file right afterwards, right? So they wrote in additional code. I think if you have any familiarity with exceptions, there's actually a try, except, and finally block inside this open method that works with the with, that says, all right, if I open a file, I'm going to definitely want to close it at the end of it. So I don't even need to write a close statement. As soon as I'm out of this code block, so you notice this, after this code here, this is a colon here, and then it's tabbed in. So all of this code in here that gets run, once you exit this block of code, it automatically closes whatever files you've made. All right. And the way this works is it says with open, so it's still the same open in file.text read and out file. So this thing is exactly the same. The only thing that gets swapped around is instead of the equal sign being here, you replace it with as, and then the fin gets put on the other side. So whatever variable name goes on this side, and this as keyword is an alias thing. So the idea is that it's going to take this thing and it's going to read it in as fin. So if you were, if you're saying it in, English for this style here, fin, you're going to read fin as whatever the stream is that I've been handed back. Fin is equal to that. This thing that I've gotten is equal to fin. All right. So if you do this one, this forward slash here is just here because with Python, if you want to comma separate, you can comma separate multiple things like this. Use them with a single with. But if you were to do this in the IDE, you would have an issue right here. It would what would happen is if you had it on the second line, it would actually give you an error because it doesn't know how to read it properly. You need to use this, forward slash to tell it, oh, this line is part of this thing. So I couldn't put this all in one line because it's a lot of crap. So I just separated with that. But the main thing you have to take away is with starts with, you only do that once, and then you open whatever file you want as whatever you want to call that, open the other file as whatever you want to call that, do your stuff here, read it in, write it, and then at the end of it, when you're done, automatically closes. All right. So do either one of these, whatever you're comfortable, whatever you figure out that you're most comfortable with. Just be aware that if you do this one, the old style, full credit, but you have to close it. If you don't close it, you're going to lose credit on it. If you do it the new style, don't need to close it. If you lose credit on it, talk to your TA or your professor and they'll give you your points back. But doing it this way is easier to not, easier because you don't have to remember to close your files. All right. All right, so that was just an explanation of that syntax. So going back to here, so if we're reading directly from the stream, right? So these are the different ways you can read it directly from the stream. So right here, I've grabbed this file, like this infile.txt right now. It's a little hard to see because, well, this thing here, this line up here is the same exact thing as this bottom one, pretty much. It's just that with open. So I've opened that as INF. So now I have that handle for INF, right? Because open hands back a handle. I've stored that in INF. Now, reading directly from the stream, I can grab this, and I can say, okay, so this file stream here, this INF file, I can go line by line. So for each line, I can print out the line directly. So in this case, I'm actually like I'm just taking the file and I'm using the stream itself to automatically read the stuff in. So if you don't need to process, if you don't need to do any additional processing, you want to just look at, the lines inside a file, or you want to just do stuff to the lines without doing any additional work, you can just read it in like this. Open it, open the file, save it somewhere, and then just do for line in whatever the file is, print out the line or do whatever you want to do to it. All right, so that's reading directly from the stream. You can do that. Um, if you care about the file as a whole and you don't actually care about like the individual lines, let's say you want to count the occurrences of the letter A or the string the inside just an entire file. In that case, you don't care about the lines, right? All you care about is you care about grabbing all the data and just processing it all at once. In which case, there's a method here called .read. So whatever file you've created, you can do .read, and then that will allow you to read this entire thing in as one big block of text. And if you were to print this thing out, it would just give you a huge, a single block of text, just one string, right? So be aware that this is when you do reads everything as a single string. It's going to retain all your new lines and stuff like that. So just be aware of that if you want to break it up from there. All right, and in this case, in this one, didn't close it because I didn't have to. I used with. In this case, I used open, so I used the old style, so I need to close it. All right, and then the last way that's useful is if you care about the individual lines and you want to retain them for later use. So you can use this method called read lines, and read lines will read everything in as an array of the individual lines. Now, the difference between this one, read lines, and just reading it directly from the stream is that uh, data streams have something called a cursor. It's where the file is. It's how the program keeps track of where you are in the file. So let's say I had used this with open here, right? And I've opened this file and I did for line in INF and I just printed it, right? Now, if I went to here and I copied this text is equal to inf.read, I pasted it in here, tabbed in properly, and I tried reading again, I would actually get nothing back from this text line because the cursor from this file here reads everything until the end of it, and then the cursor is stuck at the end of the file. So it's like if you're typing in your word processor and you get to the end of the line, that's where the cursor is located. It can't actually look back to the beginning. So if you try to do another read or read lines after that, you're going to get nothing back. So be careful where the cursor is for that. When you do it like this, where you read everything into this text item, or you do read lines and you store it into lines, the cursor is going to be at the end of the file the way it's going to be for this method where you're reading directly from the stream, but now you have a copy of that thing, so you don't need to read it again. So now from here, I can use lines and do more stuff with it. I can say for line and lines, do something, and then when at the end of it, I can go back and do for line and lines again. I don't have to worry about where the cursor is because lists don't have cursors. All right, so this thing. So if you don't care about the stuff, if it's just data that you need to read through once and then you're done with it, read it directly from the stream. If you actually care about doing multiple levels of processing, or multiple levels of processing, then you're going to want to probably use these two. All right. And again, if you want to just process the entire thing at once, do read. If you actually need to care about the lines, like I think there was like some Dr. Seuss problems where it's like find out the number of print out the number of duplicate words inside a given line. In that case, you want to use like read lines because you care about what's inside a line. All right. Oh, I actually forgot to include. So I'm gonna add a slide about writing to a file. Writing to a file is really straightforward. It's just you open the file and you do fout.write, and that's it. Writing to a file though, you can only write strings. So if you were to get an input from the user, like if you asked the user their age, and you stored that as an int, if you didn't convert that to a string, you tried writing it to a file, it would bug out, it would crash, and you would lose points on the exam for doing that. So just be aware, write is just, whatever the output name is you have .write, and then that whatever you write to it has to be a string. So make sure you do your conversions to string if you have anything that's not a string. All right. Okay, so dictionaries and tuples. Um, let's see. So with dictionaries, it's like a real life dictionary. So you have a term and then the definition associated with it. Terms have to be unique though in dictionaries, right? You're not going to see multiple entries for the same word. You will see multiple definitions for the same word. In which case, those definitions, those multiple definitions, it's fine to have it that way because for a unique key, you can have multiple values mapped to it. It might be one to one, it might be one to many, it might even be one to nothing, but it's never going to be many to many or many to one or anything like that. It's always a relationship of unique key to some set of values. All right. So the main thing that you need to know how to work with dictionaries is this structure here. Um, Setting up the dictionary is easy. It's just, whatever, name your dictionary, it's equal to, in this case, I'm going to start with an empty dictionary. As I'm doing the processing, this is the main consideration that you need to check because if you're working with a dictionary, right, it's going to be where the main thing about the dictionary is that the keys are unique, right? So this is the condition you need to check if you're putting stuff into a dictionary, right? So if I'm inserting values into a dictionary, I need to say, is this key that I'm checking in the dictionary, right? So this, by default, when you look at a dictionary, you're looking at the keys. You're not looking at the value. So this thing here is actually the equivalent of saying if key and d dot keys, all right? So you check to see if a key is in the dictionary. If it is in the dictionary, if the statement is true, if the key already exists in the dictionary, so this is like what I said. Dictionary has a unique value. If that term in the dictionary already has a definition, I can't just, I can't if I did an equals like this, right? What would happen is I would overwrite the existing value inside whatever current thing is for the dictionary. So if the key already exists, I'm going to want to add stuff to it, either via appending to a list or something like that. And in the case of a real life dictionary, it might have multiple definitions. You would think about storing multiple definitions inside a list. So I might append those values to it. If I was just, keeping track of a count of something, like an index, like what pages and stuff, I might just, add a value to it. All right. And then otherwise, if it, so this is checking if it exists. Otherwise, if it, a key can only be either in the dictionary or not in the dictionary. So we just check if it's in the dictionary, I'm going to append values to it. If it's not in the dictionary, then I'm going to create that value in the dictionary. I'm going to go to the dictionary and add that value in. And so you just do an assignment there. Now, if you look at this structure, it's exactly the same. It's really straightforward. It's just whatever your name of dictionary is here, you check, and then whatever key here gets indexed inside the dictionary that way. So if x in d, then it would be d sub x, else d sub x is equal to the value. So it's either going to be append or add, and then create here. So this structure is the same throughout whatever you do. If this dictionary name was if you called it fully dictionary, then this would be dictionary. So for dictionary is equal to a list, an empty dictionary. If x in dictionary, dictionary sub x plus equal to value, dictionary plus x, dictionary sub x is dot append value. Pick one of these, or do dictionary sub x is equal to value, right? So this is the structure for adding stuff into the dictionaries. If you want to read stuff from a dictionary, really straightforward. Key has to exist, but it's going to be like indexing a list. So if you were in a list though, you can index by values, right? In dictionaries, you don't actually do indexing. It looks like indexing. It's not actually indexing. What it is, it's keying off the value. So if I put in a value and it exists, then it will pull back whatever the value is, d sub 1. If I had a key of 1 mapped to something like uno in Spanish, maybe I map it to a string. So dictionary 1 mapped to uno. I can do d sub 1 and it will pull back the value uno for me. All right, but if I did 2 and I don't have a d sub 2 and I don't have a 2 mapped in the dictionary, I'm gonna get a key error and it's gonna crash. All right. So it's like in lists where if you do an index out of bounds, you might get an issue. So index out of bounds is an error if you're going further past the end of a list. If a key is not already set in the dictionary, you're going to get something like an index out of bounds. It's going to be called a key error because the key doesn't exist. All right. I need to add a slide for tuples, but tuples are straightforward. It's just a list with parentheses, except it's immutable. That's it. All right. Um, okay. String methods. So this one I'm not really going to go over in detail. It's here. You might want to look it over. But it's just pretty much knowing that these methods exist. And that's about it for the review for all the material that you'll need to know. So this file is located on in my drive that's shared, so you can just download it and look at the string methods. It's just more or less memorizing a bunch of the main methods that you'll need to know here for handling stuff. Um, but it's you can do a lot of this stuff without knowing the string methods. Just be aware that it exists. So, all right. I wanted to go over an exam. So let's see. Does anybody have any questions about stuff that? Uh, let's see. Yeah, the video will be up. It should stay on my channel for a while. If anything, it'll be on YouTube after it's done processing. So if it's not, just let me know. I'll make sure it's up. Okay. Let's see. All right. So I want to actually go over an exam now. So the exam that I'm going to use is so if you go to the link on my webpage, you'll see there's a study materials thing here. Let me increase the size of this. You'll see you go to this web.njit.edu/tilde UTC2. There's a study materials folder here. You click on this, it'll take you, as long as you're logged into your NJIT email address, you'll be able to access this folder. I've got all the practice exams and stuff from midterm 2 in the midterm 2 folder, so I'll actually click on this and show you guys what that looks like. I'll bring you here to this folder, go to midterm 2, and you'll see all the different files in here. So this is where the slides are. I'll update them and add them in here. But what we'll go over today is we're going to go over midterm 2 practice exam 4. This is the most recent exam from last fall semester. So it is in terms of content, is the most up to date. And let's see, so we're going to work on that together. So I've also included here midterm 2 practice exam for the code tracing. This is the thing that I'm going to be using. This is what you see here in the background. It's just a spreadsheet. It's pretty much just the same thing as this file here. Let me see. So yeah, I'm gonna look at this exam. Okay. And if you look on this, right, let's see, that's the vertical tabs. For code tracing, oh, we don't actually have the code tracing stuff. You'll have, like, you know, the grid paper on your, as in the scrap paper, and it's pretty much just this. It's for tracing code. Let's see. So what we'll do is we'll actually go through and trace some of this code here and see what needs to be done. Okay. So this is, again, this is midterm 2 practice exam for 2017 fall, right? So this is the most recent exam. Question number 1 here. This is a dictionary type thing. So again, this is like what I had, you know, showed before with dictionary stuff. So in this case, what we're going to do is we're going to need to track down what changes, so what stuff we actually need to track in this scenario. Let's see. I probably should have looked at this in a little bit more detail first. Okay. All right. So what we're going to do is we're going to start off with actually, it's a little bit so I can see. Okay. So what I'm going to do here is I'm going to look at this question 1, right? So this is question 1. And then I want to look at it and say which things are going to change in this. What stuff am I going to need to track, right? So I'm just going to call this value here n, because that's the number of turns I've gone, because there is a for loop here. So with a for loop, you know there's going to be some kind of, you know, whatever variable here is. In this case, it's called char or char. And so I'm gonna track that variable. I know char is gonna change because it's going to take on these values as I've processed it. All right. I know char is going to change, and then I know that the other thing that's going to change is this dictionary here, right? So there's going to be dictionary that's going to change because I'm doing stuff here, right? So first turn, character is nothing, n is the first turn, so nothing happens there. The value of the dictionary is going to be empty right now. All right. So the first thing I'm going to do is I'm going to see what values get passed in here. Character analysis, I'm going to pass in this string called bib, B-I-B here. All right. So because this s here is the equivalent of this. I'm passing this in. This s value is going to take on all the values in here. So now this is going to be for char in bib, right? So that means that on the first turn when I go through here, character is going to take on the first value in this sequence. For loop takes each value one at a time until it gets to the end, right? So char is going to be equal to b, right? Because I took the first value. First value for char and s, char and bib, first character is b. So now you're going to see, is b, so in this case it's checking if b is not in this dictionary. So this dictionary, we know it's empty, right? So this B is not a key in this dictionary. So if it's not a key, I'm going to add it in, right? So when you add it into the dictionary, you're adding it in like this. You're inserting that value. What is the key in this case? It's B, and then it's going to be equal to 1. So you notice in the it's exactly like I did in the slides, right? If it's not in the dictionary already, I'm going to add it using an equal sign, right? So now I've made it equal to 1. Okay. Actually, let me see if there's a way I can make these bars a little bit thicker because it's kind of hard to see. Yep, okay. I should make it a little bit clearer. Okay. Okay. And now, because this is a for loop, I'm going to check the next letter, right? So iteration 2, because I need to, for loops guarantee you that you're going to go over the entire thing. So I'm going to check the next one. What's the next letter? It's going to be I, right? One letter at a time. Now it's going to check, is I in the dictionary yet? I is not in the keys, right? So that means I'm going to have to insert it. So I'm going to keep that value there, and then I is going to be inserted using the same method here, equal to 1. Right? Now I got to check the last letter in this case. Right? It's going to be B again. Is B not in this dictionary? B is in the dictionary, right? So that means that this is false. This is not going to execute. That means I have to run this thing. So now I'm going to check out what that value is. D sub B. Right? D sub B is currently equal to 1. Get that value 1, multiply it, and save it back into itself by -1. So now that means B is going to be equal to -1. I haven't touched I, so I stays the same. And then we are done with the loop, right? Went through all the letters, done with the loop. Now it's going to return the length of the dictionary, right? So what's the length of the dictionary? There's 2 keys in here, so the length of this dictionary is 2. Answer in this case is going to be C. So there was a little bit of extra work in here where you're doing these, flipping values and stuff like that. And in the end, all you cared about was the length of the list. But you still have to be careful because, what you're inserting and stuff like that. That depends on what values get passed in here. So if this was BIG, instead of, character analysis on bib, you did it on big, you would have 3 insertions and the length of it will be 3. All right, so that's question 1. Let's see. Actually zoom in on this a little bit so maybe see it better. Alright, so this is just the code tracing stuff. I'm pretty much just demoing how you do the code tracing. So I'm just demoing the thought process that goes into tracing all the code. All right, so if you feel like you're comfortable with this, you don't have to stick around for the stream. It will be, it should be posted in completion later. So you can just skip ahead and watch the free response section if that's what you care more about. But I'm just going to keep going through the rest of this. All right, so question number 2. Here what we're looking at is we're looking at some method called substring. It's going to, let's see, it's going to do index A. Let's see, it's going to take this value, store this index A. Doesn't look like, okay, so index A looks like it's going to change. All right, so I'm going to write that down somewhere. I'm going to track that. index A is going to possibly change. All right, so what else might change in this case? Looks like, do I actually add anything to return string? So in this case, it looks like I'm not touching return string at all. So return string doesn't need to change. Let's see. And then anything actually changes in this one? Besides index A. I guess there is this A sub index of A, right? So that might be something that we're interested in. Oh, did not want to do that. A sub index of A. So we'll actually take a look at that. Take a look at what that looks like. All right, so first turn index A is going to be 0, and then that's just going to be a, well, right now first turn that technically is nothing, so we'll just skip that for now. Alright, so the first time we go through this, we're going to have to pass in this aha string, so that's going to be A. Now, let me see. We know that A is equal to aha, and B is equal to ha. Alright, so let's look at this thing then. First turn, what we're going to do is we're going to look, alright, first turn we're going to trace this. While true is a while loop that is always going to run, so we're going to check if index A is greater than length of A. So length of A in this case, we know length of A is aha is A, so length of A is 3. Index A starts at 0. 0 is not greater than 3, so we're going to skip this. Go to the next one. Now we have to check elif A sub this. So this thing at right now, index A is actually going to be 0, right? So this is going to be A sub that, and then we do 0. Right, so now this is a slice. So what we need to do is we look at aha and see how this thing slices. So slicing is, in this case, is if I don't have an index at the beginning here for the slice, it just says start at the very beginning, cut up to, but not including whatever this index is. So the 0th index is here. If I don't want to include that, that means this string here is actually equal to empty string, because I'm slicing from the beginning up to the 0th index, which is the first character, but not including it. So it's going to be an empty string. So then you can check, is the empty string equal to B, which is ha, and that is not true, right? So this is false, skip this, go to the next one. And now we just want to check, is B in this thing? So is B and is ha in this empty string? In this case, false, so you don't do anything. So what you do is you have to, so you skip all of these 3 statements were false, so you continue till you hit the bottom here. And then now you want to do index A plus equal to 1. So index A 0 plus equal 1 is going to be 1. All right. Now turn number 2. We finished with this. So while true requires us to keep going until, you know, we figure out some way of getting out of it, either returning or breaking out of it, right? In this case, there's no break, so we have to hit some kind of return to get out of this while true statement. All right. Now you check, is index A is 1 greater than 3, right? 1 is not greater than 3, that's false, so you don't execute this. And you check, is A, this one is A sub index A, right? So that means go up to, start at the beginning, go up to but not including the first index, so that's just going to be A, right? So A is not equal to ha, that's false, so that's going to keep going. So actually, let me write that down first. So that's just A, right? A is not equal to ha, so that's false. Go to the next one. Is ha in A? No, that's not true either, so we have to increment the index again. So now that's going to go up by 2. Go up to 2, right? Loop is still going. Let's see, now this is going to be A sub 2, which is going to be equal to AH. Now this thing, first thing it checks is 2 greater than 3, false. Don't do that. Do the next one, check the next one. Is A sub 2, which is A equal to ha? No, that's false. Is ha in A? That's false. So we're going to increment that to 3. All right. This next one here, this is going to be a sub 3, right? And that's just going to be the full string there. And so first things first, check, is 3 greater than 3? False. Continue the next one. Now you want to check, is aha equal to ha? False. Then you go to the next one here. Elif, is ha in this thing, right? Which we've determined is aha. So we know that this ha is here in this aha, right? So now that means we're going to return this thing. So this is true. We execute this. Return a sub, a slice from beginning to index a, which is, this value, which is aha. So that will return, let's see, none of the above in this case, because the answer that it's going to return is aha. So this one, the answer to this one is E. None of the above. The answer to that one was what? C? Yeah, that was C. Okay. Okay. That one kind of sucks to do because of the slicing. You need to keep track of where the stuff is so that you can do the slicing properly. This is definitely one where you want to keep track of all the stuff inside a table or something, so you're not, losing track of where you are. And so yeah, once we hit that return, don't execute any more loop, completely kick out of this function and just, print it out. Okay. Question 3. All right, so for question 3, let's see, what is this? A for loop here. So I know that if there's a for loop, I'm going to want to keep track of the whatever that is. So in this case, the variable is I. I'm going to keep track of that. All right. What else do I need to keep track of? Let's see, do I need to, looks like I'm going to append stuff to image, right? So image is going to be something I keep track of. And then what else is here that's interesting? That's probably worthwhile to keep track of. So we have word list, sub I, and word list. Actually, what I'll do in this case is, because I don't want to bother tracking it, I can do negative I minus 1, and then I can just look it up after there. All right, so this is a string method called split. What split does is it takes a string, and by default, whatever value you provide in the parameter is going to be what it splits on. The default value for splitting is on spaces. So when you do this text.split, what it's actually going to do is going to take that text, right? And it's going to make it into a list of strings that look like this. So all for 1 and 1 for. Right, so that just splits this entire thing out into all these strings. Right, takes the text, whatever this string is, splits it, drops it into a list of individual words. Right, so that's what this split method does. I just took this thing, took this value, dropped it in here, took it, split it. Now I have this list of words. Right. So let's see. First step, nothing. Image is going to be empty. I is nothing, and this value is nothing. Doesn't exist. Oops. Come on, stop autocorrecting. Okay. Now, let's see what happens on the first turn. So let's start processing this. So we're actually going to also have to generate something here, right? A range of len of word list. So let's len of word list. How many created this word list? So what's the length of that? That's 1, 2, 3, 4, 5, 6, 7 things, right? So this is going to be range of 7. So a range of 7 is going to generate something that looks like this, right? Right. So that range is going to generate a sequence here. It's kind of like a list. Think of it as a list when you do the range thing. 7 items here starting at 0. So this is your range that you're going to come back on. So I is going to take on each of these values. So for the first value of I is going to take on the first value as 0. And then what we're going to do here, we're going to check, you can also do this calculation. -0 is equal to 0, -1 is -1. All right. Now we can check this. Word list sub I. What's word list sub 0? Word list sub 0 is going to be the first thing, so all. And then it's going to check against word list sub -1. -1, negative indices count from the back. -1 is the first one, so all. If word is, so if all is equal to all here, right? These two are definitely, all is equal to all. I've compared this one to this one. All is equal to all, that's true. I'm going to append that word that I just, append the I value in there. So now image is going to be the list that contains the value 0, because this is the value of I, append I to it. All right. Now I need to keep doing this. Next value of, let's see, next value of I is going to be 1. Then this one is going to be -2. All right. Because I'm just going to calculate this. 1 times negative is -1, -1 is -2. Now I want to check word list sub 1, which is 4. Right? 4. Against word list sub -2 here. That one. All right. So 4 is equal to 4. That's true. So I'm going to append that value as well. So that's going to go 0, 1. Just appended that value. All right. So keep tracing this. What you're going to find is that it's going to, I'm not going to complete this because it takes forever to do. But the idea here is that all you're doing is you're going to check this word with this word, then this word with this one, then this one with this one, then this one with itself, then this one with this one, then this one with this one, then this one with this one. And if all of them are, if they're equal to each other, then it's going to insert that value. So what you just saw there, as I went through it, I went 0, 0 is equal, 0 and -1 are the same. 1 and -2, 2 and -3, 3 and -4, -1, -2, -3, -4. So you're going to compare the same word, right? So you have this thing. So that's the same comparison. So that's true. So that index is going to get dropped in. Then so that's 0, 1, 2, 3. Then 4 compared to -5. 5 compared to -6, and 6 compared to -7, and all these are true. So I'm gonna, every single time, I'm gonna keep dropping all these in. So by the end of this thing, you're gonna have, which one is this? 0, 1, 2, 3, 4, 5, 6. When you get to the 6th one, at the end of that, that is going to be this list, right? So this one is going to be your answer. It's going to be D. This is just checking for duplicates across the whole thing. Right? Okay, let's see. Next one, question 4. Okay. So question 4. Tracing this again, what I'm going to do here. So for loop, immediately I know I'm going to need to track letter. What else gets changed in here? Let's see. I set a value word here, right? Is word changing at all? Nope. Don't change word. Prior. You do a check here for prior. Oh, there's a storage for prior here. There's possibility that you're going to change what prior is equal to, right? So we're going to have to track that. And let's see, it looks like this out value can be multiple things, right? So out might change, so we'll track that as well. Right, so first turn letter is equal to nothing because we haven't started yet. Prior is the empty string, and out is nothing either because we haven't set that to anything. So first time through, what are we going to do here? We're going to grab each letter in word. So we know that word is equal to boo, so we're going to take the first letter of boo, which is B. All right. So B is, let's see, if prior is equal to letter. Prior right now is the empty string. Is the empty string equal to whatever value is currently in letter? Nope, these are not equal, so skip this. But if you look at this, right, so I didn't cover if-else statements for this one because the assumption was you guys would be familiar with it from previous. I'll go over this again, this part really quickly. So this if-else statement here, this is one conditional block. This if until this else is one block, and then this if until this other if, right here, it's another conditional block. So when you have two conditional blocks that are in sequence like this, they're going to run in series. So they are mutually exclusive from each other. That means that stuff that happens in here will have no effect on stuff happening in here. So we check this, and then we have to check this. Whereas, in this statement, these are, this one is mutually exclusive. So if this is true, then this one doesn't get executed. We don't need to check this. But these two, because they're two separate blocks, we have to check them regardless. If this one was true, right? If this thing is true, then we execute this, but then we still have to check this one because it's a separate logical block. All right. We check this one. Empty line is not equal to B. So we skip this thing when we check this next one. Now, this thing here is kind of wonky because it's checking, it's a flip of this first one, right? So if we know if this is false, we know that this is going to be false. So this is going to have to, this is automatically false as well. So we said this is false, this is also false. So this logical block here, if this is false, then I hit this else block, I have to execute this, right? So now prior is equal to letter. So prior is now going to equal B, and then out is going to be equal to word sub 0. In this case, it's also going to be equal to B, right? Because this else block got executed. All right. Now, second turn, next letter in the word is, no, not a 0, sorry. It's an O. So now we have to check is letter, is O equal to, is prior equal to O? Is B equal to O? Nope, that's false. We know that this is false as well because these two are exactly the same condition checking, so this has to get executed. Now prior is going to be equal to letter. Letter is currently equal to O, so prior is also equal to O. And then we set out equal to word sub 0. So if you notice right here, out when it gets set is always equal to B if you hit this statement here, right? It's the only time it changes is if it goes into either of these other ones. So if you're ever in here, you're not going to need to change the value of out. All right, so last letter in here is O again, boo. Is prior equal to letter? In this case, prior is O, letter is currently equal to O, prior is equal to letter, right? So now this is going to say, oh, so this is true. So now I have to execute this stuff. Out is now equal to the empty line, right? So out got updated from B to the empty line. Now I hit this continue block. So continue says skip all of the rest of this stuff and then go to the next iteration of the loop. So you're going to skip, so in this case, when you hit this continue, you don't run this check again. Continue says skip the rest of the stuff and go back to the beginning and then run the next iteration. But the thing is, we're already at the end, so there's no other iteration here. We had hit the last O, right? So that means we're done with this loop, completely done. Don't need to check anything else out. And then this print statement, so then after that, we just need to print it out. So we just look, this is going to say print, and then this says it's going to be a list containing two values, prior and out. So you need to look at prior. What is prior? It's equal to O. Out is equal to empty string, so this one is going to be A. This prior is equal to O, out is equal to empty string. Drop those values inside a list as the print statement says, and you get that back. All right, let's see. 5. Oh, this one looks just like, okay, so this one is an index one. Looks like it's just indexing. Question 5. So this is, I think this is nested indexing. So dictionary, and yeah, so it's a nest. It's dictionary access, and then whatchamacallit, and then an index afterwards. Right. So if you see something like this, right, if you see multiple indices after a value, what you're going to need to do is you need to process it left to right. So you need to do, this is technically the innermost thing that you have to process first. And then this is the next one. You substitute whatever value you got back from mixed key sub 1, you know, and then you'd go and you index whatever value you got from there. If this had a third tier, you would want to go and do that indexing as well. Like you want to go another level in. I actually have a I think I have it posted on my. I think I have something in here. Um, I'm gonna post something later that has an explanation. It has additional exercises for uh, more nested indices. But let's just look at this for now. So mixed keys, the first thing so again, like I said, you have to start at the left side, right? Left to right, innermost to outermost thing. So innermost one is mixed keys is a dictionary, so this is going to look for the value one. This isn't going for the index one because remember, you can't index a dictionary. The one there in a list might have been the second element because it counts 0 to 1, but in a dictionary, these values can swap around. There's no guarantee of order, so you can't actually do indexing on a dictionary. This is a key. All right, so you're gonna look for the value 1 in here. If I typed in the string 1 and I tried to search in this list in this dictionary, you're not gonna be able to find it. But this 1 here, this does exist. This key does exist here, right? So when I do mixed keys of 1, so the first thing I do is I check mixed keys with the key of 1, and that is going to return to me this dictionary entry, right? Which is going to be another dictionary, actually. So this is a dictionary nested inside a dictionary. 0 and then 0 val, right? So when I did this key here, right, I keyed the first element here, right? I'm looking for the key of 1. I found it. I return whatever's inside there, right? So I have mixed key sub 1. That's this thing, right? Now this thing is a dictionary again. So if I tried indexing on this, if I tried putting like the value 1 in here, this would not work. But because this key exists here, this 0 exists here, right? Now the next thing I'm going to do, actually let me just copy it from here. So I'm actually taking this element, right? Mixed key sub 1, I'm going to substitute this value back in. So that's the thing that I'm looking at. And then I'm going to check 0, key 0 of this, right? And this dictionary also has a key 0, right? And that's going to return this string value here, right? It's going to return 0 val, right? And that's the string that you're going to get back. So it's going to return C. All right. So that's how you deal with dictionaries that are nested inside dictionaries. If this had been, let's see, if I done like, let's say if I did another tier, right? So if I did something like this where I take 0 val, so 0 val is a string. Now this thing I can do, you know, I can do this index, and this index here would be R, or the string R, right? So this thing here is actually would be the equivalent of something like this. So it would have been mixed keys sub 1, sub 0, sub 2. So if you had something like this, do the same process. Start with 1, get this dictionary back from the 1, get this string back from this 0th key, and then now I can index this thing and get the R back from there. Right? Let's see. Question 6. All right. So with these types of problems, when you do Boolean stuff, easiest thing to do is to evaluate all of these things first. Don't bother like, you know, going through this stuff until you've evaluated this list. All right. So I'm gonna evaluate this thing first. So the first thing I'm gonna say is, okay, so there's the first value is true, so true is always going to be true, so that's just true. 0 is greater than -1, that's also true, so that's going to evaluate to true, right? Not true, so not true is false, not false is true, so that evaluates to true. 2 modulus 2 is 0, 0 is equal to 0, that's also evaluated to true. Then true and false, that evaluates to false because and requires both elements to be true to be able to give you the, you know, the true. So for and, both of them have to be true for the final result to be true. So these are all conditions that evaluate to true and false. So I've taken this Boolean list and I've converted it just to the most basic values. So I took each of these, crossed it out, filled in with the word true or false, and just gone all the way through. Now, this thing is going to loop. So this is not a for loop in this case. This is actually going to be checking other stuff. So what I need to check in this case is there's going to be index is a value that's going to be changing, right? And then I'm also going to want to know pools of index, right? So first time around, index is going to start at 0, and then this thing is, oh, sorry. And then this thing I don't care about yet. I haven't started yet. All right, so the first time I go through this while loop, right? I want to check, let's see, first time I'm going through the while loop, pools index is equal to 0. Bool sub index, what is this? Bool sub index is equal to true because it's the first one. Bool sub 0, that's going to be true, right? So if this thing is true, then this while loop will execute. Remember, while loops only execute when this condition is true, right? So I've done this, I've looked up bool sub 0, it's true. While true, I'm going to execute this. So index is going to be incremented by 1. Sorry. Index is going to get incremented by 1. All right. The next thing that you're going to do, so this is a while loop. You haven't hit a terminal condition yet, so the only way you can exit this while loop is if this condition is equal to false, right? So you're going to have to keep going. So the next thing you're going to check is while, so index sub, so index is still equal to 1, while bool sub 1, because we're looking at the previous value. Bool sub 1 is also equal to true because this is the first element, so that's true. This is true, so you're going to increment that. So this thing's just going to keep going until you hit the false one. So I'm just going to do this kind of quickly. So this is still true. And then increment that. Fourth time. True. I'm actually tracing through this one because it's a little hard to track some of the stuff if you're not careful here. Okay, so that would still increment to 4. Okay, now this one here is going to be bool sub 4, right? 0, 1, 2, 3, 4. This is false. So I've gone to while bool sub 4, that's false. So that means this is not going to execute. I'm not going to increment index again. So when I print out index, I'm going to print out whatever the last value of index was for, which is 4. So that's none of the above in this case. Okay. Question 7. All right, so this is a nested loop one. So I'm going to need to keep track of I and J. So this one, the way I keep track of this one is I actually use additional spaces to keep track of all the extra stuff. So I know that I is going to be equal to, it's going to be in range of 2, so I is going to take on those values. And then I know that J is going to be in the range of 1, so J is going to take on that value. All right. So first time through, actually I can just skip that. First time through, I is going to take on the first value of 0. Now, this outer loop starts here. I've grabbed this 0 value in, which means that while I'm in here, I need to go through this J until it's completely done. So if this range was not just a single item, if this is like 10 items, for every single occurrence of this outer loop, this inner loop gets run fully. So if this was range of 10, J would get run 10 times, and then it would finish and then come back out and do the I loop again. Right? So it starts this thing here, and then you go and you do, and then you start, so outer loop executes as many times as it's called, and then inner loop gets executed gets executed that many times again for the outer parts. So if this ran twice and then this ran 5 times, you would get a total of 10 executions. So there should be 10 lines at display here, right? Then because every single inner loop has to get executed in full for each outer loop. That's the way you should think about that. All right, so J will take on that first value 0, all right? So then right here, grabs that value. It's going to print out I, J, and then this print statement end thing just says don't add a new line because default for print is a new line. You just add a space to the end of it. All right. So what's I and J? So that's going to be 0 and then 0. All right. So that gets printed out, and then there's a space at the end of that. Right. Now this loop here. Let's see. This loop we finished already, so we don't need to execute it again. So we have to come back out and do the outer loop, right? So I'm actually going to do something else here in a little bit. I gets the next value, which is 1 from this sequence, and then it's going to come in here and do J, grab the 0 once, and then print that. So that print statement is just going to keep append. It's just going to append to the end of this thing, right? Because end of no new line just says print that out. Right, and then I think that's the last part of the loop. That should be finished. So what you'll get is 0, 0, 1, 0, which is D. So I'm going to do a different version of that one where I'm going to actually make it so that there's an additional loop on the inside, because we've had that on an exam before, and I want you guys to be familiar with how to deal with this. All right. I and J. Right. So first time the loop goes through, I takes on the value of 0. J will take on the value of 0 as well, and then when you print it out, it's going to print out 0, 0. Right. Now, last time we immediately kicked out of J because J only had one value in it. Right. So we immediately went back and started doing the next part of I. But in this case, J has 2 values in it. So I'm going to need to go through this loop again. So you notice I didn't iterate I yet. I still hasn't iterated. Right? I'm going to do this. Make it a little bit longer so it's a little bit more clear. So J hasn't finished looping, so I need to come back. I can't come back out from here. I can't go back out to the I loop yet. I need to finish up the J loop, right? Now this is going to print out 0, 0. Oh, it's going to append to this one, 0, 1. Because I is still 0, J is now equal to 1, and I was printing I and J, right? Right, and then now I finish with the J loop. Now I can go back out and I can do the I. So this thing is still, this is 1 sub A. Because I still had to do the B. Oh, sorry. I'm actually not done with this loop yet, because this thing, it goes up to 2. So now this thing is going to come out here, and it's going to print out 0, 1, 0, 2. Right? And that was the second part. And now I'm done with the J loop. So then I can come back out. And now I'm actually on the second loop of the I value. So now for this one, then I have to do the same thing again. 0, 1, and 2. Right? And then so for those, it's just going to append the rest of those values to it. Then I'll do 1, 0, 1, 1, and 1, 2. Right? So that's what happens if you have multiple stuff on the inside. You have to loop multiple times to get, you have to deal with the inner loop completely before you come back out. All right. So that's it for nested loops. Let's see. Q8. All right, so question 8, let's see, make dict. All right, so there's going to be a dictionary, there's a for loop. So for loop, I'm going to want to keep track of the word. What else do I need to keep track of? Looks like initial, right? Initial is going to be something I'm interested in because I track it here. And then I also want to do the dictionary, right? I want to keep track of what this dictionary is. So word is not defined yet. Initial value not defined yet. And then dictionary is just an empty one to begin with. Right. So again, split method, pass this string in. I'm going to split it first. So this split is going to result in this. You broke my heart. Oh my god. And you said this /here is just to tell it that this single quote should not be considered its own thing. It's the actual quote character. All right, so let's see. I split a thing. So let's see. First turn here. The first word I'm going to take in is you. Right. Now, initial of word sub-zero. This is initial of words is equal to word sub-zero. So that's this word sub-zero. It's actually going to be capital Y. So this is the part that you have to be careful about. So you have this Y here, right? This is a capital Y. When you get to this U over here, it's actually not going to be the same Y. It's going to be a lowercase y. So you have to be careful with that. So capitalization matters when you're talking about keys. The uniqueness is a factor, all right? So remember, these have to be unique. Capital letters are different than lowercase letters. All right, so you're going to check if initial not in D. Oh, I just realized it's initial D. Okay, anyway, if initial not in D, so dictionary is empty right now. Then you have, so you're going to drop, let's see, so if it's not in there, then you're going to add it, right? You're going to add this key, and you're going to do the word. So in this case, the key is Y, and, well, the string Y. And I'm going to map it to a list that it starts off with the word, and the word is you. Right? Then you don't do this, you go to the next word, you, and then the next word is going to be broke. Right? And lowercase b is the initial value in word sub-zero, right? And b is not inside this dictionary, so what I'm going to do is I'm going to add it to the dictionary. I have, oops, y is mapped to u, that's fine. And then I'm going to want to add b and map b the word broke. Right? So what this is just going to do is, if you're looking at this, is every single time it finds a new word, adds it to the dictionary with the first letter as a key, and then adds it like that. When you do find a word that has the same letter, that begins with the same letter, instead it's actually going to do an append. So let's actually see what actually starts with an append here. What would actually have an append? All right, so when and will are both starting with the W. So when you hit that point, you're going to get something that looks like this, right? So actually it's going to be further down. Have your dictionary with Y, U, B, map to broke. I'm going to be skipping a few of these things for now, but you'll have a lowercase w, right? And lowercase w was mapped to when the first time, right? But when you hit this wheel here, right? This is a W again. This W is already in this keys, so it's actually going to append it. So you're not going to overwrite this value. You're just going to come here and you're going to add the string will. And that gets added in. So at some point that's going to get dropped in there. So what you want to do is that at the end you're going to want to print out the length of this thing. You return the dictionary and you print out the length. So what we were saying before is when you were looking at this dictionary, right? It's every time you find a unique beginning, a unique word beginning, that's the one you want to keep track of. So what this is going to do is you're going to say Y happens once, lowercase b happens once, lowercase m happens once, lowercase h happens once, lowercase w happens twice here, right? When and will. So we only count that once. Lowercase y happens once, lowercase s happens once. We already counted will. Part happens, lowercase p happens once. So these are the keys that we're going to be working with. And that's a total of 8 characters. So the length of this dictionary should be 8. It's going to be B there. So that one you might need to trace through fully. That's probably going to take the longest to trace through because you have to just drop all the stuff into the dictionary. So just be careful with that. I'll finish tracing out the rest of it at the end of this, and then post it. Okay. All right. Question number 9. So this is a file processing. It looks like. Yeah, it looks like it's gonna read stuff from the text. All right. So with this, this thing is actually a good example of what happens when if you don't know, if you're not familiar with what you're supposed to do with some file processing stuff, you can always look back into the problem. Usually in the multiple choices, there will be information, like, there'll be examples like this that you can take and use them. So what you'll want to do is, if you have something and you're like, oh, I don't really know how to work with files, just go back and look at some of these and see, oh, okay, so I can use a read or something like that. And you'll know right here, you can see, oh, inf is equal to open. So you can open a file that way. All right, I have to close it. So these are things you can look at to remember what you're supposed to do if you forget. So let's see. Okay, so for this question, assume that the file edgar.txt exists and has the following content. So this is stuff inside this Edgar file. All right, so what I'm going to do with this function is there's a for loop here. So I'm going to track something that happens in there. So that's going to be word is going to be in there. Let's see. What else do I care about? Different is something that looks like it's going to change. Let's see, content is going to be the same as it goes through, so the only stuff that really looks like it changes is going to be different in word. Let's actually trace some of this. So let's see, so Edgar is this thing here, this text, right? So this thing is just going to be the affair is so simple and yet baffles us altogether. All right, so that split method here grabs the whole thing in, splits it into these list of words. All right, so now what we're going to do here is we're going to start counting and the word, right? So what is the first word that we're going to grab in? It's going to be the. Let's see, if length of word, so length of the. String stuff is annoying. Okay, the is not equal to num length. Num gets passed in here is 3. So this is false, so we don't do anything, so we go to the next word, right? So different doesn't change. Different starts at 0, doesn't change. Let's see. Oh, sorry. Were we getting like random people because of the killing floor thing? Sorry, I'll change that. Can I actually change that to something that's not? This is so annoying. This is so annoying. I can't actually find anything here. Creative. Alright, I'll set it to creative. Sorry about that. You can actually do. I tried searching for like education, and there's like some really not safe for work stuff. There's also some random crap. So education did not work. Did this? What the fuck? It looks like it's set back to killing floor. Oh, are you kidding me? This is ridiculous. Creative. Is that a game that's called creative? Sorry, I don't use Twitch often enough to be able to. Oh my god, this is ridiculous. Are you able to edit this stuff, Chris? Oh, actually, let me see IRL. IRL is a thing. Sorry, my eyes are kind of dried out. Why is this not changing this friggin' setting? Ugh. Oh, okay, it looks like it got set finally. Okay. Sorry about that. Alright, where was I? Oh, so the killing floor thing is a joke about how the exams go. But let's see. Okay, so this one is, I'm still processing this file. Right, so the first word I grabbed is the. The is equal to, let's see, length of the is, I'm actually going to move this over because I care about, I actually want to track this, right? Different, starts at 0. All right, length of the word is 3. 3 if, so we're checking if they're not equal to, right? So we're just saying every time we find a word that is, the length of the word is not equal to 3, I'm going to increment different, right? Because that's the value that we passed in from here. All right, so the first word is the, different doesn't get increment, it stays at 0. Next word is going to be affair. Affair is 6 characters, right? So 6 is not equal to 3, so that's different, so that's going to increment by 1. So what this thing is doing is that every time you find a word that's not of length 3, it's going to increment different, and at the end it's going to return different, right? So easiest thing to do in this case is just to go through and count the number of words that, have a length that are not equal to 3. So the is, 3. Affair is 6 letters, so that's 1. Is 2. So is 2. Simple is 6. And is 3. Yet is 3. Baffles is 7, so that's another one. Us is 2. That's another one. Altogether is 10 characters. So that's 7 total characters that are 7 increments. So 0 plus 7 is going to be 7. It's none of the above in this case. So all this thing is doing is just counting the number of words that are not of length 3. Yeah. All right, last multiple choice question before we get into the for response stuff. All right, let's see. Fred is equal to that. So let's see. We're gonna want to keep track of for loop is there. So for loop has thing as the variable. That's something we're gonna keep track of. Frequency is a list. I mean, a dictionary that we're gonna want to keep track of, and I think that's it. Okay. So let's actually go and do a little bit of processing on this. So Fred is that string. So when we split it, it's going to be equal to power concedes nothing without a demand. All right. So let's see. Before we start, thing is equal to nothing. Frequency is an empty dictionary. All right. So for each thing in Fred.split, so we split this thing, we split the string, and we grab each word from it. So each word. So the first time, thing is going to be equal to power, right? And then power is going to be equal to Fred.count of thing. So .count is a string method. It counts the number of occurrences of this substring, right? So count. Oh, actually, no. Fred. Oh, actually, this is something I probably need to look at in a little bit more detail. Chris, can you check this really quickly if I can do a count on so if I do the count on a string, it's going to do just check the number of occurrence of the substring, right? Just verify that that's correct. Sorry, because I'm used to seeing this count being done on a list and not on the string. That said, you can do counts on strings. It should be a substring thing. It's just going to count the number of times power occurs in this substring. So power happens once. So this thing should, and that's just going to set that equal to, what is thing? So power, okay. So power should be mapped to, sorry, this is string power. Is going to be mapped to 1. And then so each of these things is going to do, power is equal to 1. So that's the first one. Then the next thing it's going to check is going to see concedes. And then the one after is nothing. And then without. And then a demand. So let's see. So the only kind of interesting one that you're going to see is when you get to A, because A, when you're doing a count inside a string, it just checks the number of occurrences, right? So this substring power only occurred once, concedes is only going to occur once, nothing is going to occur once, without is going to occur once, but A is going to occur 1 to 2 times. So that's the only one that has multiple occurrences. But the thing is, you don't care about that. You just care about the unique keys in this case, because you're doing length of frequency. So at the end of it, it's going to be each one of these things, right? It's going to be power, concedes, nothing, without, A, and demand. So these are going to be your keys. So what is the length of that thing? There's 1, 2, 3, 4, 5, 6 keys. So that's going to be a length 6. Okay, that's just going to be A. Yeah, remember frequency, when you do the length of a thing, it's just the number of values in it. All right. Okay, so let's see. That should be it for the multiple choice. This is the, all right, so now we're going to do the free response stuff. Let's see. All right. What am I doing here? This is 2017 fall. New. What is this? CS100 2017 fall midterm 2 solutions. So I'm just going to type a few things. Number 11A. Can you guys see this clearly on the screen, or do I need to increase the size of the font? Okay. Okay, so what we'll do here is, let's see. All right. I need to reduce the size of this window for myself so I can actually see this stuff. Okay, so let's see. This thing is a function called, so writing functions is just going to be def, whatever the name of the function we tell you, hemispheres, and then it takes parameters, right? Problem 11 is pretty much always going to be turtle problem. I think it's going to be that way for the final as well. So write a function. It's called hemispheres. Takes 2 parameters. You just write it like that, straightforward. And then what you need to do with this thing is it's going to say that the turtle is initially set on the edge of the circle at a point that the dividing line should be drawn, right? So the function hemisphere should exit with t in its initial position and orientation. Do not make any assumptions about the initial up and down state of the turtle. Right. So there will definitely be a turtle problem on the exam. There pretty much always is, even on the final. Right. So this line here is important, where it talks about initial location orientation. The reason for this is because you care about how you have the turtle set up, right? So you don't know the initial up and down state. So the first thing you always want to do with this is just t dot pen down. You just want to put the turtle down, so you're guaranteed that it is in the correct position, or in a correct position to start drawing. Right. So let's see. When you draw a circle, right? T dot circle, you have to provide it a radius. So all we're going to do in this case is we're just going to do t dot circle is equal to radius. So we're going to draw that circle. Now, that when you draw the circle here, what it's going to do is it's just going to draw this. It's just going to do the circle. So, yep, wrong one. Sorry, that's a different problem. Run. Okay. So I actually need to call this. Sorry. Import turtle. This is equal to turtle dot screen. T is equal to turtle dot turtle. Hemispheres. T100. Okay. So I'm just going to call this function really quickly and take a look. And oh, it doesn't actually show that on the screen. Okay, so what that did was it actually drew a circle like this one over here. Oh, it did show up on the screen, just laggy. Okay, so yeah, it just drew a circle, right? Which is half of what we want to do. We still need this line here, right? So if you want to draw this line here, you need to actually, you draw the turtle. It's gonna end up over here. Now you need to get it to draw this line. So turtles always draw in this direction, right? Counterclockwise, unless when you specify this radius, as long as the positive radius is going to draw in counterclockwise. So that means that I'm going to end up facing this way again. I'm going to be in the same direction as I started. So that means I want to turn 90 degrees left in this case, because turtle's facing this way. I'm going to want to turn it up so that I can draw that vertical line. So I need to turn, in this case, left turn, and then I'm going to turn 90 degrees because I want to draw it straight up the line. Okay. Now if I did t dot forward here, this is the common error that a lot of people did. You have to remember the radius of the circle only goes up to the middle here, right? So it's only going to go from here to here. So that's not going to work. So you need to do radius times 2, right? And now that you have, now that's going to bring the turtle all the way up to here at the top. And then once it's at the top, it's facing upwards. So we need to get it back into this bottom position. So the easiest thing to do is t dot back radius times 2, because you want to move it back the same distance. And then you want to reverse the direction to get it to go back into the original position. So that's just right turn. So you did a left turn to get it to face up. Now you want to do a right turn to get it to face back. So that should work. Sorry, it's gonna load up kind of fast and go through, and I forgot the command to make it stop. T dot. Is there a place where I can have it halt? T dot wait? That doesn't look like it. Now there's some other command, I don't remember it off the top of my head. Sorry about that. Put this import at the top of the file. Okay. I'm gonna keep these here. I'm gonna comment this one out though, because I don't want it anymore. So that's part A. Alright, so part B is gonna want you to draw additional things. Right? So this one is going to get, this one's going to have, so remember, part B always requires that you use the function that you wrote in part A, right? If you don't use the function that you wrote in part A and you redo it again, you're going to lose points because you're not supposed to do that. Right, so this one is called multispheres. It's going to take 5 parameters: t, size, ratio, angle. Right. And then this one is going to, let's see, when you call it, it's going to do this. So what it's going to do is it's going to draw a circle, then it looks like it's going to turn and then do a calculation fit and then try to either make it bigger or smaller. So if your ratio is greater than 1, the circle is going to get bigger and bigger. And if the ratio is less than 1, it's going to get smaller and smaller. So it's just going to keep, drawing each one of these until it gets through. So if you're drawing multiple things right away, you know this is going to be some kind of for loop thing, right? For I in range, and then what's the range going to be? It's going to be num, because that's the number of circles that we're going to draw. So that's the number of iterations we're going to want to go through, right? So let's see. What does this function call hemispheres require? So when you call hemispheres, it takes a turtle, right? So we have the turtle, which we have from here, this parameter. We're going to pass it in, and it takes a radius, which in this case is going to be size. All right. So it's going to take that size in, draw that first one, all right? And then what do you need to do after it draws that circle? It needs to turn a small amount, right? It needs to turn some amount. So t dot, in this case, let's see, what does this say? Angle is the counterclockwise rotation of successive circles. So counterclockwise means it's going to be left turning. And it's going to left turn by angle because that's the parameter that we use for that. So now we've drawn the circle, we've turned it. Now we need to change the size of this thing, right? So what you do in this case is it's just going to be size times equal ratio. Because what you want to do is you just want to take the current size of it, and then you're going to want to multiply by the ratio. So this resets the size, so when you come back up here, this size has been changed. So if the size was 1/2, now, well, if the size was 100 and the ratio was 1/2, you multiply, you multiply 100 times half, gets you 50, saves 50 back into size. We can come back up, it's going to draw the next one with the size is equal to 50. All right, so that's how you do multispheres. All right, this one is dictionaries. All right. So function called count vowels. Define count vowels. Takes one parameter, text. Right. And this says it's going to return something. It's going to return a dictionary. So as soon as you see that there's going to be some kind of return, just create your thing right away. So I'm going to call this one D because it's a dictionary. So just call it D because I'm lazy. All right. So this dictionary is going to return each word in a text that is a key and the corresponding value is the number of vowels in that word. So in this case, we're going to be looping over this thing, right? So we have this string that gets passed in, this text. So if you just do something like this, right, for x in text, right? So we know this is going to be a for loop because we're going to iterate over this thing, right? If you did this right away with just text, what's going to happen, right, is that this thing is one large string. So when you try to iterate over this, you're actually going to iterate one letter at a time, right? So you don't want to do that. You actually want to get the words because you want to. The consideration here is you want to get the number of vowels in each word, right? So words, now we can do text.split, right? So that split method that came up previously in the I think there was some in the free response parts. It's going to convert this large string into a list of words, right? So then once you've done that conversion, you can do for each word in words. All right. And then now you can start checking for things. All right. So let's see. In this case, what is it going to be? You need to find the number of vowels in that word. All right, so if we want to check for vowels, we can actually see. We can actually make a variable that has all the vowels in it, right? A, E, I, O, U, A, E, I, O, U, and I want to include caps in there because caps are vowels as well, and I don't think this. Oh, this thing you don't need to keep caps because this one says explicitly that it's all lowercase letters and these are the vowels. So I'm gonna make a thing called vowels there. Okay. So, but here what I want to do is I want to check if I want to count the number of vowels inside each word, right? So the first word government, I need to count the vowels. As a person, I can just look at it and go, okay, there's an O, that's one, E's two, there's another E, so there's 3 vowels in that. But computer is not able to figure that out on its own yet, at least. So we need to actually, tell it explicitly what we want to do with it. So we need to track the number of vowels in that word, right, for each word. So you notice that when I make this vowel count variable here for tracking the number of vowels, I don't put it outside here because this vowel count is word specific. Whereas if I put it outside here, it would be counting across all of the words. I just want to count I want to reset it. I want to reset this value for each time I get a new word. So if I grab government, vowel count gets set to 0. I'm going to do my calculations and then I'm going to store that somewhere. And then once I'm done with that, I'm going to grab the next word, which is of, and then I want to reset vowel count to 0 again because I want to keep track of the number of vowels for each word and not the number of vowels across the whole thing. Right? So for this one, it's going to be a nested for loop, char in word. So what I'm going to do is I'm going to take that word, right? I'm going to iterate over this whole thing. I'm going to check it and make sure. I'm going to see if each word is if each character in the word is a vowel. So if char in vowels, right? So if I found a character, if I got a G, if G is inside vowels, which is not, go to the next one. If O is inside vowels, it's true, right? O is inside this list of vowels. So if O is in there, I'm going to go ahead and I'm going to increment this value, vowel count plus equal 1. Right, so I'm going to keep track of all of that for each of the characters. Now, once I've gotten all of the characters in, now I'm going to want to map, I'm going to want to map this thing to something in the dictionary. So what do you do here? This one is actually, we don't actually need to care if the word is already in the dictionary in this case. Government of the people. So the occurs multiple times, right? But we only care about the mapping of the vowels inside it. So we don't actually need to check in this case. You can check to see if the word's already in the dictionary. I think it's probably better to do it that way. So if word in D, if it's already in there, continue, right? But if it's not in there, we're going to want to insert it. So we do D sub word is equal to vowel count. Right. So this is that dictionary structure thing. But in this one, instead of appending to it, we just continue. In this case, it's still going to be this one. So whatever word we're doing checking here, it's going to be the key in here. So if the word is in the dictionary, that's going to be the key. And then we're going to map it to the vowel count. Right. So that is. And then what do you have to do? Do you have to return? Yeah, you have to return something at the end of it. So then you want to return D at the end of it. Okay. So again, this part technically is optional because we don't care. We can rerun it multiple times because we're just overwriting the value. The happens 3 times, but we only care about the number of vowel occurrences in that. So technically, you could have just done D subword is equal to vowel count, but this is the full correct way of doing it if you want to do it like this. Okay, and then number 13 is the last one. Okay, so number 13, this is going to be file IO. All right, so this is a function named longest online. So if you notice, like I don't even read over the question in detail at the beginning. I just go ahead and I fill in all the stuff that I know how to do right away. In the file, out file. Because, you should know how to, declare a function right away. That's annoying. Yeah, so this thing, so what it's going to do is it's going to find the length of the longest word on each line. So right here, when it says each line, let me slide that over a bit. See that? Oh, that's too high up. Okay, so that should be good. You should be able to see it. All right, so right here, this word, the keyword here is, I think it's still cut off. Each line. Kind of annoying. Oh, that's like completely off the screen. Sorry. Let me slide this over a bit. No, that's not really helping because remove this stuff. I actually need to edit the way this image shows on here. Oh, it's kind of a pain. Hopefully that doesn't take up too much of the screen. Just want it to be readable. Okay. So let's see, I'll just verify that. It's gonna be kind of close actually. That's kind of a pain. Let me just shrink it down a little bit. All right, that should work. All right, so the key thing here that I want to look at, right, is I want to look at this thing, each line. So this thing says I'm going to look at each line of the file, and I'm going to write that to a file. I'm going to write that length. Let's see, writes that length. So it finds the length of the longest word and then writes it to the file. So in this case, right here, it's saying that I'm only going to process it once. I just need to write stuff out to the file, and that's it. And so I don't need to process this multiple times. So, I mean, I can use read lines, but I can just read directly from the stream as well. So I'm going to do that. So I'll do the demo with both things. Let's see. Inf is equal to open, and then open has to take in this in file name, right? Because I'm passing in file, and then default value is going to be read, so I don't need to provide that. Out f is equal to open out file. But I need to pass that in with a W. So I'm going to comment these out because this is not the way I like doing it. I'm going to use with open in file as inf comma open out file as out f. And then so for this one here, what I'm going to do is I'm going to go to the bottom. And if I was, if I was working with this thing, I would want to make sure I close it. So right away, I'm going to remember to write down somewhere. If I did this old style, I'm going to write down right away that I want to close the file off. Right. All right. So I've opened the file, and because I don't care about rereading the file, I can just go ahead and read it directly from the stream. So for a line right? So I'm just going to grab each line, and then what I need to do for each line is I need to track the longest word, right? So let's see. So I'm going to have to do words for a given line. Equal to line.split. I take that line in, whatever this line is here, I'm going to grab it. Money is just something you throw. I'm going to want to take that line in and split it into the individual words. All right. Max is equal to when. Oh. Okay. So the length of a word, technically, you can do this where you know that the length of a word is going to be the minimum length of a word is going to be 0, right? So you want to set it at the minimum, and then you want to check to see if anything's greater than this, right? So if you were checking like if you were checking numbers or something like that, you would actually have to do it with you have to start it with an actual value in there calculated from something. You know, it would if you had like a list of numbers. So if you had like a list of numbers that you were processing, right, you would actually have to do something like line sub 0 or something like that, right? Because with numbers, there's no guarantee that that's going to be the small. You can't pick the smallest number. But when you have words, you know, you can guarantee that the length of a word is going to be at least, you know, it's going to be at least 0. You know, a space is just, you know, it's one character, and if it's like an empty string, you know, that's the smallest length of a word. You can't have negative length words, so we can just automatically set that to 0, right? Now, so now we want to check for word in words, so because we want to find the word with the greatest length, right? If len of word, if the length of each word is greater than max len, because every time we find the greatest length, we want to set it max len is equal to len of word. And so we're going to check each word. We're going to see if the length of whatever word we just came across is longer than whatever the longest word we found previously was. So monies is what? This is 7 characters because it includes the quote. So it'll do 7. So length of 7 is greater than 0. So that's true. So now we set the max length to 7. Sorry. Now you check just next. That's 4. 4 is not greater than, so you skip it. Something is 9. 9 is greater than 7. So then you reset it. So once you get to the end of that, right? So once this loop completes and you've gone through all the words, now you know the max length. So what you can do then is you're going to write that to a file, right? Out f.write write max len. But this is not correct because max len is a integer, right? It's a number because len returns a number, so you need to convert that into a string, right? So and this also says that you cannot write if the line in the input is empty, then the output should also be empty. So you need to write an additional condition here. So if max len equal to 0, continue. Oops, double equal sign. What the heck? Okay, continue. And then this has no return statement because it's a file IO, so this will write the information out to the file, and then you should be able to grab the file from there. All right, and I think that covers everything. Oh, and there was these things here. So if you use this in file and out file open method like this, you need to close them at the end. But since I'm using this with, I don't need to close it at the end of that. All right, so that should have covered everything. And I guess we'll stick around for maybe like 15-20 minutes and answer any questions if anybody has. Yeah, sorry about setting up the the channel with the wrong topic and having random people pop in. I didn't even notice. The pound sign is just there for commenting stuff, single line comments. If I wanted to do this thing as a multi-line comment, what I would do is I would do this. I'd do triple single. Oh, no. This has a specific behavior that part. I do triple double quotes like that, and then I can actually do a block quote. But it's just easier to do single line quotes. Oh, you have to change it to a string because write does not accept integers. So actually, let me show you how. Actually, I don't have files written in advance, so I can actually just do something like this. I'm not gonna call it with open. Let me comment some stuff out real fast so I don't get any weird drawings. All right, that's done. That's done. Okay, so I can do something like this with open output dot txt comma right, and I'm just gonna run it as outf, and let's see, outf dot right. I'm gonna try to write the integer 1 out. All right, so when I try to run this, you get this error here. Right argument must be string, not integer. So you cannot write integers out. So when I did this thing before, when you get len of word, len of the word is going to be, you know, a number. So you can't write integers out. So you have to do this conversion to a string first. Does that make sense? Yeah. Let's see. Yeah, I have no idea what that thing is. Creative. Is this like a game or something, or just a random image that they threw on there? Sorry, I literally use Twitch like twice a year for these reviews. That's about it. So I have no idea what the hell I'm doing. So I'll have this stuff posted on in the folder as well, so you guys can grab it and take a look at it to do some additional reviewing. If that's it for questions, then I'm gonna call it a night. Thanks for showing up. You know, feel free to throw me an email if you have any questions about stuff for the exam. We should be posting room assignments in the next few hours, or tomorrow probably, and it'll be the same as last time pretty much. So yeah, it should automatically be posted to Twitch once I close this. If anything, I'll make a copy of it and drop it on YouTube. That's usually what I've done. But I think the Twitch version should have a record of the logs in case you have questions about, you know, if you asked questions and they were answered there, if you want to check them. But yeah, that should be about it then. Let's see. I'm usually up super late. I work remote, so I'm usually up to like 2, 3 a.m. because I'm just used to doing it, and I wake up pretty late in the morning. So don't expect an answer. If you write me an email, don't expect an answer like you know, um, like first thing in the morning. I get up like around 11 or something. So yeah, it's probably easier to get a hold of me later at night than anything else. My email is, let's see, c2@njit.edu. In case anybody doesn't have it, you can just grab me from there. I should have a link to it on my website too. The school website, there should be a link to that. So yeah, you're better off emailing me later if anything. All right, so in that folder also there should be some additional previous exams with answers and stuff. You should be able to look them over from there as well. Let me take a quick look and make sure. Yeah, so there's some previous exams in here with, you know, code tracing, some extra stuff, I guess. Let's see. Yeah, there's some previous exams and there should be solutions for them as well, if you want to just look those over. Yeah, this is all the midterm 2 stuff. All right, so good luck, everybody. Exam's going to be on Monday. I think it's, what, 4 o'clock starting? Yeah, it should be like around 4, and then there's like a later section if you can't make it. Make sure that if you absolutely cannot make the earlier section, make sure you message your TAs about it so that they can log that information. We need to keep separate attendance sheets, so it's better if we know that you're going to be unavailable for the first exam. That way, we don't, mark you completely absent. Um, that's about it. But yeah, as far as like details and stuff, it's if you feel like you're not familiar with something and you're a little bit concerned that you might not get it right, or you don't remember it exactly, make sure you look back at the multiple choice sections because there's usually like some kind of solution in there that you can use. It's usually somewhere in there that you can look something up and be like, oh, okay, this is kind of what I need to do. Um, and get more practice and make sure you balance your time between the multiple choice and the free response because that's usually the hardest part. It's just getting the two worked out properly because you spend too much time on one and it's gonna cut you on time for the rest of it, so just be careful with that. And that should be about it. All right, so again, if you guys have any questions, feel free to email me, Chris or Jason, or your TA or professor. Thanks a bunch, Chris and Jason, for helping me out with this. It's yeah, it's a lot of it's a lot of work to go through and help dealing with the answers and everything while I just cover the stuff. So really appreciate the help. All right, so good luck on the exam on Monday. Take care, guys.